This video talks about lessons 2 and 3, which are understanding variables and expressions, pages 7 through 11, and then also using the product property of exponents. We'll start with understanding variables and expressions. So what is a variable? A variable is a symbol used to represent an unknown number. Now it can be a letter, it can be a symbol, but it's just something you use to represent a number that you don't know. What is a constant? A constant is a quantity whose value doesn't change. So numbers 3, 6, 14, 75, those are constants. They're numbers whose quantity we do understand. Some examples here. We've got 6 minus 3x. 6 is a constant, 3 by itself is a constant, and x is a variable. It represents a number we don't know. Here, 71wz plus 28y. 71 and 28 are our constants. W, z, and y are our variables. Now, what is a factor? When you can multiply two or more quantities, each one is a factor. For example, to get 6, we multiply 2 and 3. So 2 and 3 are factors of 6. What is a coefficient? Coefficient is the numeric factor of a product that has a variable in it. So it's the number that is being multiplied by one or more variables. In this example, we have some terms, and we need to identify the factors and the coefficients. Over here, we see 7VW. 7 is being multiplied by V and W. So the factors are 7, V, and W. The coefficients in this set is 7 because it is the number that's being multiplied by the variables. Here we have negative 5 RST. So the factors are what are we multiplying to get this? We are multiplying negative 1 and 5 and R and S and T. So those are our factors. Now what is the coefficient here? It's the number that's being multiplied by the variable. So negative 5 is our coefficient. The next one we have is CD. What are we multiplying to get CD? We're multiplying C times D. So those are our factors. Now what is our coefficient? There isn't a number being multiplied by CD here explicitly, meaning it's not being shown, but we can always assume an unseen coefficient of 1. If there's no coefficient, we assume it to be 1. So 1 is our coefficient in this case. And this last one is y over 3. So it's written as a fraction with y on the top and 3 on the bottom. Now, this means that we have 1y over 3. And what are we multiplying to get this? We're multiplying 1/3 times y. Now our coefficient is the numeric factor, so our numeric factor here is 1/3. Now let's look at expressions. Expressions have different terms, and the terms of an expression are the parts of the expression that are separated by a plus or a minus. So here we have x minus 4xym. This has two terms. It has x and 4xym, and they're being separated by subtraction. In this expression, we have three terms, 3x plus 2y minus 10. 3x is being separated from the next term by a plus. 2y is being separated by a plus and a minus, and then 10 is our last term. Here we want to identify the terms in each expression. So we look at what's being separated by a plus or a minus. So here's our plus. On the left side here we have 6xy. So 6xy is one of our terms. Now after the plus sign, but before the next minus, we have 57w. So 57w is our next term. And then after this minus sign, we have 24x over 5y. So our last term is 24x over 5y. Now in this next example, m plus 3mn minus 5t over d plus 8 minus 9, we start on the left, and our first term before the plus sign is m. So m is one of our terms. Our next term, being separated by a plus and a minus here, is 3mn. And our next term, being separated by a minus and a minus, is this whole chunk right here, this 5t over d plus. And finally, our last term, being separated from everything else by the subtraction, is 9. All right, so now we have a situation. The telephone company uses the expression below to determine the monthly charges for individual customers. And here's our expression, 0.1m plus 4.95. First, we need to identify the constants. In this term right here, we have 0.1m. 0.1 is our constant because it's our numeric factor. And m is our variable. So we can say m is our variable right here. Then we've got plus 4.95. 4.95 is also a constant because we know what numeric quantity that stands for. So our constants are 0.1 and 4.95. Our variable is m. The next question says how many terms are in the expression. So we count how many things are in the expression that are separated by a plus or a minus. So we have one term, and then a plus, and then a second term. This expression has two terms. Now let's look at using the product property of exponents. This is lesson 3. It's on pages 12 through 16. Exponents just show repeated multiplication. Exponential expressions have a base, which is the big number, and then they have an exponent, which is the little number to the upper right. Now this just means how many times do you multiply the same number. 5 to the third means we multiply 5 3 times, or we have 5 times 5 times 5. Now let's look at these examples. This is 7 to the third. 7 is what we're multiplying, and 3 is how many times we're multiplying it. So we do 7 times 7 times 7, which gets us 343. Here we have 1/2 to the 5th power. That means that we multiply 1/2 5 times. So we have 1/2 times 1/2 times 1/2 times 1/2 times 1/2. That's 5 times. Now when we multiply fractions, we multiply across the top and across the bottom. 1 times 1 times 1 times 1 times 1 is 1. And 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So our answer is 1/32. Here we have 0.3 as our base, and we're multiplying it 4 times. So it's 0.3 times 0.3 times 0.3 times 0.3 again. And when we multiply 0.3 times 0.3 times 0.3 times 0.3, we should get 0.81. Now let's look at 10 to the third. 10 is our base, and we're multiplying it 3 times. So we have 10 times 10 times 10. And when we multiply 10 times 10, we get 100 times another 10 is 1,000. Now when you multiply tens, you really just need a 1 with this many zeros. The product property of exponents tells us that if we have a base to a power and we're multiplying by the same base to a power, we can simply add the powers of that base. In these examples, you can see how this works. Here we have x to the 5th times x to the 7th times x squared. Now that means we have 5 x's times 7 more x's times 2 more x's. Now remember, our base is what we're multiplying, and our exponent is how many times we're multiplying it. So here, obviously, we're multiplying x, and we're multiplying it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. So this would be x to the 14th power. Now we would get the same answer if we took x, which is the same base all the way across, and added all the exponents. So 5 plus 7 plus 2 equals x to the 14th. When you have the same base and you're multiplying them, you can simply add their exponents. Now let's look down here. We don't have the same base all the way across. We have some m's over here and some n's over here. We can only combine the ones that have the same base. We can say m is to the 3 plus 2 plus 4 power. And the n is to the 6 plus 7 power. That gets us an answer of m to the 3 plus 2 is 5 plus 4 gives us 9 power, times n to the 6 plus 7, which is 13. Order of magnitude is the nearest power of 10 to a given quantity, and we can use this to estimate. So sometimes things aren't exactly at powers of 10, but they're close, and we can use that to estimate. So here, if we look at this example, it says in 2006, the fastest supercomputer's performance topped out at about 1 pflops. 1 pflops is equal to 10 to the 3rd tflops, and each tflops is equal to 10 to the 12th flops. We need to know what was the computer's speed flops. Now we have 1 pflops. We have 1 pflops. I'm going to abbreviate p. Then that means we have about 10 to the 3rd t flops. I'm going to abbreviate that t. Now this is how many t flops we have. Each t flops is equal to 10 to the 12th flops. So if we have 10 to the 3rd t flops, and we multiply it by how many flops, 10 to the 12th, we can figure out what the computer's speed is in flops. And as you can see here, it works the same with numbers as it does with variables. We have the same base, 10 and 10. And because we have the same base, we can find the answer by simply adding their exponents. So this is 10 to the 3 plus 12. 3 plus 12 is 15. The speed of the computer in flops, or f, is 10 to the 15th